All right, this is the 11.3 section video where we try to figure out the formula for finding the area of any kind of regular polygon. So let's review a little bit here. Regular polygons are polygons that all have congruent angles. So every angle is exactly the same. And they have congruent sides. So all of the sides are exactly the same. So hopefully you remember what a three-sided regular polygon is called. It is an equilateral triangle. And then a regular four-sided polygon is called a square. So before we can actually get into figuring out the formula, let's discuss what a central angle of a polygon is. So the central angle of a polygon is a polygon angle that has the center of the angle as the vertex of the central angle. So the center of the circle is the vertex of the central angle. And then you have segments that are drawn to vertices. So in this case, the pointy parts of the polygon. So there's a segment between C and A and a segment between C and B. These are consecutive vertices here, and that creates a central angle. And if I want to figure out the measure of that central angle, I just take 360 degrees, which is all the way around a polygon, and divide that by the number of sides. So in this case, this polygon has 5 sides. So I take 360 divided by 5, and I get 72 degrees. So each central angle in this figure is actually 72 degrees. So this is 72 degrees. This one here is 72 degrees. This one here is 72 degrees, and that one's 72 degrees. So if I add up all 5 of those 72 degrees, I'm going to get 360 degrees. So let's try to figure out some angle measures here. So we're going to pretend you can't see the stuff that's on the screen. But if I want to figure out the measure of angle FGE, so I want to figure out the measure of angle FGE, that's a central angle. So I'm just going to take 360 degrees and divide that by the number of sides. In this case, there's 6 sides going around. So the measure of angle FGE is 60 degrees. Sorry about that. Moving on to angle BAF. Angle BAF is an interior angle of the polygon, and that's going to bring back our interior of a polygon angle formula, which is going to be n minus 2, so we know how many triangles are inside of this, times 180 divided by the number of sides. So there are 6 sides here, so I take 4 times 180, so that's 720 degrees, and then I divide by the total number of sides, which is 6, and I get 120 degrees. So 720 divided by 6 is 120 degrees. And then the measure of angle GKE, that's a 90-degree angle here. I'm drawing to the side here. I've got a 90-degree mark. That's a 90-degree angle. Now, if I want to figure out the measure of angle GFE, so I want to figure out the measure of this angle right here, okay? When we draw a segment from a center to a vertex, okay, that's going to split this angle equally up in 2. So if we discussed over here where the measure of angle BAF is 120 degrees, each angle going around this polygon is 120 degrees. So at vertex F, this whole angle here is 120 degrees. So the measure of the red angle is going to be half of that, which is going to be 60 degrees. So 60 is half of 120 degrees. Now, before I can really get into what is the formula for a regular polygon, finding its area, I've got to define 2 segments for you. First of all is a radius and apothem. And I know it sounds like I, kind of misspoke that, but that's really what it's called, is apothem, all right? A segment that goes from the center to a vertex is called a radius, kind of like the radius of a circle. If I drew a circle all the way around this polygon, okay, the circle would touch here, 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 and here. So the radius would be this segment here that goes from center to vertex. Now this segment going from center to side, again, going from center to side, and it's always a 90-degree angle here, this is called the apothem. So the radius is always longer than the apothem. So regular polygons have the same area formula I wrote at the top, but you're going to notice as I go through here, I'm going to show you many different area formulas. Don't write this down. This part is not what's important. Just the fact that I want you to know that we do have different area formulas, but we can actually make a universal formula here in a moment. So just follow along with this. So If I've got a triangle, the formula for a triangle is 1/2 base times height. So that's the formula for finding the area of a triangle. For finding a four-sided figure or a quadrilateral, it would just be base times height. Or if you have a side or a square, you would have side times side. If I've got a five-sided figure, the formula gets funky. So this now becomes 5/2 times a letter A times a letter S, which, gosh, I wonder what that means. If I have a six-sided figure or hexagon, the formula is 3 times this A and times this S. If I have a seven-sided figure, it's 3.5 times A times S. If I have an octagon, it's 4 times A times S. And then for any universal figure, okay, in this case here, I don't know how many sides it's got. It's going to be 1/2 times A times S times N. And it's like, wow, that's funky. The A stands for apothem, so it's 1/2 times the length of the apothem. And then S stands for the side length, so times the length of the side. And N is the number of sides. And you'll notice going all the way through here, I'd either had like 2 or 3 different variables. Actually, I only had 2 variables, but when I came in here, I had 3. One set of 2 here could actually be combined to 1, okay? If I do side length times number of sides, that can always be reduced to something else, because the side length times the number of sides is always going to be the perimeter of a figure. So if I take the length of a side and takes it and times that by the number of sides, that's the perimeter of the figure. So the one I care about right here is this one I've highlighted. If it's got 6 sides, here's the formula, 3AS. So let's see where that comes from, and that's going to fill in with this one as well. So you're going to see how this comes together. So just to review, how do I find the area of a triangle? Okay, there should be a right angle here. So to find the area of a triangle, you always take the side lengths that are surrounding the right angle. So 1/2 base times height. So 1/2 of the base times the height. So 6 times 8 is 48 times half is going to be 24. So again, that's just help us try to figure out where this 3AS thing is coming from. Okay. So we know the area of a triangle is 1/2 base times height. So here I'm going to change, instead of having one triangle, now I have that inside of a hexagon. And I have 6 triangles inside of here now. So I have 6 of these 1/2 base times height things. And that's trying to help us get to this area here. Again, side length of a polygon is going to be just from here to here. All right. And apothem is just going to be from center of center of polygon to edge of polygon. Okay. So let's move on to the next slide and look at this a little bit more in depth. So again, I have some variables that I can combine. Okay. The side length here, or the side length of this polygon, is exactly the same as the base of this triangle. These two variables are representing the exact same thing. So side length and base of a triangle are the exact same variable, because this could also be S here as well. Okay. The height of the triangle, so going to figure out the height of the triangle, I want to figure out the area of this triangle. I go from here to here. That is known as the height of the triangle. That is also the apothem of the polygon. So these two variables are exactly the same, okay? And then number of sides, in this case, I've got 6 triangles. So I can go 1/2 base times height, all right? That's the area of a triangle, but I'm going to change this now. I'm going to change the base into the side length, because these variables are exactly the same. And I'm going to change the height. The height and the apothem are the exact same variable. So then I'm left with, instead of finding the area of the triangle 1/2 base times height, I have 1/2 S times A. And then how many triangles are here? There's 6 triangles inside of this. So I'm going to add a 6, because there's 6 of them. So 1/2 times 6 is 3, and S is S, and A is A. So this formula for finding out the area of a regular hexagon follows through with 3SA. And that also follows through then with the general case of any polygon. Okay, any polygon is going to be 1/2 times the apothem times the side length times the number of sides. And to do the 3AS, we just combine these two together, because there were 6 sides, and we're doing 1/2 times 6. So this is 3AS. So when I tell you there's one area formula for all regular polygons, it's really true, and it's this formula right here. So the formula for any regular polygon is 1/2 times A times S times the number of sides. And that can be reduced. It can be reduced because side length times number of sides is the exact same thing as the perimeter of the figure. So anytime I think about the regular area formula for a polygon, it is always going to be 1/2 times A times this P, which stands for perimeter. So whenever you hear me say it, I'm going to say 1/2 apothem perimeter. So the area formula for a regular polygon is 1/2 apothem perimeter. So when we put this into play and try to figure out how to do a problem, in this case, here's my hexagon. My apothem is 20. My side length is 25. And all I do is fill it into my formula, 1/2 apothem perimeter. So 1/2 times my apothem, which is 20, and my perimeter is 25 times 6. 25 times 6 is 150. So 150 times 10 is 1,500 centimeters squared. So that's where this comes from. I just fill it in. Same deal with this one. So I want to find the area of this regular polygon. Okay, I'm going to take 1/2. My apothem is 5.196, and my perimeter is going to be 6 times 6, would be 36. So 1/2 times my apothem times 36 is going to be 93.5 units squared. So I think you're going to see this is a pretty easy formula. Right, this one's just another take on this. So a regular decagon has an apothem of 7.6 meters and an area of 155.8 meters squared. What's the perimeter and length of each side? So I'm just going to fill this into the formula. 1/2 apothem perimeter. So 1/2 7.6 times my perimeter is going to equal 155.8. So I just fill that in. 1/2 7.6 times my perimeter equals 155.8. I'm going to combine my 1/2 and 7.6 to make 3.8. So 3.8 times my perimeter equals 155.8. Divide both sides by 3.8, and I'm going to be left with 41. So my perimeter is 41 meters. And then to figure out a side length, just take your perimeter and divide it by the number of sides. So a decagon has got 10 sides. Divide 41 by 10, and I get 4.1 meters for each side. So I really do feel like, even though this is kind of long-winded to give you an explanation of where the formula came from, I think you'll find this formula quite easy to work with. All right, so that gives us our assignments then. On Monday, I want you to do 1 through 5. Tuesday, I want you to do 6 through 13. And Wednesday, I want you to do 14 through 17. And when you're done with those, you can send them to me in an email. So I hope you found this presentation helpful. Thanks, and have a great rest of your day.